So we've got a really great panel. Simone Costello, graduate process engineer in the water team at Arup. Simone holds a Master of Chemical Engineering from the University of Melbourne. Welcome, Simone. Give her a round of applause. We've got Sunny Singh. Sunny's currently pursuing his Bachelor of Civil Engineering at Deakin University, and he's also a stormwater engineer with the City of Greater Geelong. So welcome, Sunny. And Eve Smolineska is a project engineer with Civil Infrastructure and holds a first-class Bachelor of Engineering from RMIT, and is also the chair of the Victorian Civil College. So welcome, Eve. And Ishraf is a fourth-year undergraduate student majoring in electrical engineering and electronic engineering at Swinburne University with a passion for energy. Not a bad profession to get into, Ishraf, I can tell you right now, particularly in renewables, the energy transition, smart and nano grids, solar energy and AI as well. So just a reminder, you've got Slido up on the screen there. Don't miss this opportunity to sort of pick the brains of our Gen Z engineering panel at the moment. Simone, I want to first come to you. Can you tell us a little bit about how climate change, we heard that climate change is looming large over your careers, even in the early stage of that. How has it impacted your career choice so far and the pathway that you've chosen?
Yeah, for sure. So when I was going through high school, there was this big emphasis that, climate change was coming, and that we were the generation who would be experiencing the effects of climate change, but also were responsible for tackling the challenge. So that was definitely on my mind as I moved into further study. And so that led me to sort of combine my interest in sustainability, in earth sciences and in technology. It led me to study a Master of Chemical Engineering with a focus in water as well. To be very honest, when I was at university, it's quite hard to keep that big picture in mind and that purpose. At least for me, I was very focused on submitting that next assignment, doing that exam. But fortunately, since I've joined the industry, I've been working at Arup for 2 years now, I've really seen some of the projects that we're doing, and I'm quite hopeful that we could really make an impact through engineering.
And I guess, congratulations on making it through university. I must admit, I just scraped through mostly with a P. But I got there. I got the qualifications, so well done to you on getting through. What are the most promising innovations that you're sort of seeing from your perspective in terms of addressing climate change?
Well, I mentioned some of these projects that really sort of ignited my passion again, and at Arup we've been doing a lot of work in water for hydrogen, which I found super interesting. I guess if we're positioning Australia as a leading hydrogen exporter, there's been a lot of conversations around, net zero, reducing emissions, hydrogen as an energy source, but there hasn't really been those conversations around the water supply we need to get there. We need a lot of water to produce hydrogen and for the cooling of the processes. And I think it's been fun having these discussions about, in 30 years in 2050, when we're under extreme water stress from scarcity and competition for resources between society, the environment, and something like the energy sector, that's going to be a really interesting challenge, I think, ahead in our careers.
Such a key thing, I think. We talk about this term that's thrown around all the time about Australia being a clean energy superpower and green hydrogen playing a huge role in that, but we're on the driest inhabited continent, so that's a really big challenge you see for the hydrogen industry, the green hydrogen industry.
Definitely.
Yeah, excellent area to be in. Ishraf, I want to come to you now. We've talked a little bit before. Let's just cut to the chase, really. You've got a bit of a passion for electric vehicles, haven't you?
Yeah, true, yeah.
What's your favourite EV?
Oh, Tesla Model C for sure.
Tesla. So now, given your area of engineering is in such high demand, you'll probably be able to buy a Tesla within your first year. So that's a positive thing, really, isn't it?
I'll try.
So tell us about what you find the most promising thing, in terms of innovation to combat climate change.
Yeah, so the climate change is really affecting humans and the whole ecosystem so far. So in my perspective, the electrical engineering perspective, I think changing from normal vehicle for EVs is one of the best option I can reckon. And also, if I start from the manufacturing process of EVs, they're using rechargeable lithium-ion batteries, which is using some environment friendly the components which with the whole process, which help to reduce the carbon emission. And also, if I talk about mainly the Paris Agreement, because it says that from the next century, the temperature is going to increase by from certain amount. So our goal, like using EVs, like electrical vehicles, is basically to reduce the increasement from like 2 Celsius degrees or up to like 1.5 Celsius degrees. So that's like this kind of help with the climate change as well. And also, considering Australia, transportation is the third largest sector, which like around like 17% from the total pollution is like with transportation.
Ishraf, I completely agree. I think EVs have got a massive role to play, and even just not from a vehicle perspective, but that vehicle to grid in terms of grid resilience. What's holding us back? Why is Australia such a laggard in terms of EV uptake?
Yeah, the main reason, like so far, the current stats shows that in 2022, the total EVs, the manufacturing is just around like 8.2%. But if you consider China, it's like the whole public transport, it's like around 40% of the whole transport is like EVs. So that's the difference. Like in Australia, still in the process of converting from live to EVs. So that might take some time because it got some challenges as well. So gonna talk further.
Excellent. Thanks, Ishraf. Sunny, I want to come to you. This is a bit of a passion of mine as well. During my time at City of Melbourne, we did a lot of work in water-sensitive urban design, and I still, I'm on the South East Water Board, so I think there's a lot of both integrated water solutions, engineering solutions, green infrastructure, all of these sort of things working hand in glove to address these challenges. Can you tell us a little bit more about the work that you're doing on water-sensitive urban design with the City of Greater Geelong?
Yes, absolutely, Aaron. So first thing, climate change, it's real, it's happening, and it's entirely up to us to be prepared for the consequences of climate change in future and better prepare our cities. So as a part of my role with the City of Greater Geelong, we work in preparing the Geelong Council, like the area, the city, to deal with the consequences of climate change in future. So as a part of that, we develop those green infrastructure assets, as you mentioned, like wetlands, rain gardens. We put them strategically around the city so that they can deal with the rainwater, excessive rainwater in case we get a big flood event, or they can treat the water and release it to the river system and protects the health of our creeks and rivers. So that's something that we do. And apart from that, we also work on stormwater management strategies and flood management strategy. So as an example, we are working on modeling the central Geelong catchment, which is one of the oldest catchment in the City of Greater Geelong. So that catchment contains a lot of residential, commercial, and industrial developments. So we are modeling that catchment, and that catchment was designed way back, even when I was not born. So it was designed on some of the old standards, which are not valid at this point of time, and the properties in that catchment get flooded very easily. So which is a big problem. So at this point of time, we're modeling catchments and trying to come up with the flood management strategy, and essentially trying to see how will the flooding happen in future, and trying to better prepare ourselves for the consequences, and alerting the residents that this is going to happen. So this is how you have to deal with it.
Yeah, so a little bit more of living with the fact that we're going to see flood. There's a person that you should speak to, Sunny. Lucia Cade is sitting down here, former chair of South East Water. So this is all about connections. So I would be hitting Lucia up during the break just to pick her brains about your career path. Eve, I want to come to you. Similar sort of question. You know, what are the sorts of challenges and the sort of biggest areas of innovation that you see in terms of combating climate change?
Yeah, so the biggest innovation I see, particularly in the construction industry, is the reuse of waste. So this can include materials such as recycled plastics, recycled glass. But recently there's been huge innovation happening in the world of using recycled crushed concrete to produce new concrete. Naturally, with how all the infrastructure jobs now, or large buildings are coming to the end of their design life cycle and need demolition, this is a huge opportunity to be reusing that captured carbon and chucking it into a new material that can be used on the new infrastructure projects.
Massive area. We heard quite a bit about it in terms of the embodied energy yesterday. Any examples, any case studies you can share with us as to what's working well?
Yeah, so the biggest project that's been happening recently was actually the Rail Projects Victoria sponsoring on the airport link. sponsoring a trial for some concrete mixes, and that actually included testing 40 MPa and 50 MPa concrete, engaging 3 different suppliers, all the major suppliers for concrete, so Holcim, Boral, and Hansen. They all developed their own mixes. They were given space to experiment themselves. And these results actually were beautiful, were tremendous, enough that this concrete was actually poured into a structural pour and used in real-life example recently. And now, maybe after some more durability studies, this is actually the next step is to get Australian standards revised and get these materials approved, potentially through specifications such as Vic Roads.
And is that what's
happening at the
challenge?
moment.
Is that what's holding us back
Yeah,
at the
so
moment?
that's one of the challenges. Naturally, Australian standards and Vic Roads does not allow or allows very limited use of recycled materials, particularly in concrete. But the second biggest challenge is the cost. Naturally, recycled materials have a higher amount of cost, and that's something clients need to take into account when budgeting on upcoming projects.
Fantastic. Look, I want to come straight to, there's a lot of audience questions flowing in on Slido, so please do get your questions coming in. There's a question from Rob there, which I just want to come to each of you. So, Simone, we'll start with you, but it's a really difficult one, right? So, how do we change the discourse or the conversation? What's the biggest change that you want to see in the discourse or the conversation around climate change? Simone?
Oh, that's a tough one.
If you had your magic wand and you just said, righto, we're not going to do this or we're going to do that, we're going to speak about it in this way or in that way, what would it be?
I think we just need to start having broader conversations about this, like amongst everyone. So even people who are not engineers or technical specialists, I think just having these conversations around climate change and the role that we're playing is really important to gathering interest, support, and sort of seeing how people who don't even work in the industry can still contribute to, achieving a better future for everyone. I was just like out at dinner the other night with some friends, and they're like, "Oh, what are you doing this week?" Going to this conference to speak, and they're like, "Wow, like, you guys are engineers saving the world." And I was like, "That's really cool, but we just don't really think about that because I feel like we really focus in on our work and our projects, but when we share that a bit wider, it's like quite inspiring and encouraging to see other people get engaged with that."
Yeah, absolutely. Sonny?
Yeah, so something that I would want to see, especially for my workplace, would be a lot of funding and then being able to innovate, because these are essentially the 2 biggest problems. So with the local governments, as I'm working with at the moment, so the biggest problem is that we can't really innovate. So when we get funding is rare for us. When we get it, we basically can't spend it on something thinking of, okay, let's see how it goes. So we need to be sure that we are using the public money wisely. So one thing that I would like to see amongst you all as well would collaborate with each other and try to come up with innovative solutions. And the greatest thing, in my opinion, would be collaboration with the universities. So this is something that has worked for the city of Greater Geelong in the past few weeks. So as an example, like Deakin University, they have like a set of ponds, and because I'm studying with Deakin University at the moment, so Deakin was working on those ponds and redeveloping them into a set of wetlands. And trust me, they are world-class wetlands. They are a set of 5 wetlands all joined together because they're trying to make Deakin carbon neutral by 2030. So I took City of Greater Geelong on board, and they are now partners with Deakin, and they're trying to monitor how that entire thing functions. So in future, if that thing works, we have a proof, and then we can do something similar in future. So universities have got that ability to try and test out things. So one thing that I would like to see is more collaboration with the university and industry.
Excellent, like that. I think, cities as a lab, a living lab, it's got a lot of conversation. There's been some good case studies, but we can definitely ramp that up further. Eve?
Probably just industry-wide, just more renewable energy and more similar funding investment and more options.
Yep. Ishraf?
Yeah, I'm thinking as engineers, we always need to be initiative when finding innovative solution for a certain problem. In my case, it's of course renewable energy sources or maybe EVs related stuff. And also I agree with Sunny what he mentioned. It's about the collaboration with universities. So at Swinburne, we collaborate with Siemens, and we got the Siemens Hub, something like that. So it got even students have the access to work with the actual real projects as well. So it helped, and also the uni is getting lots of funding from different kind of sponsors as well. So I think the collaboration is really important in this kind.
A question from Wahidul, was sustainability included in your engineering curriculum, and how can engineering curriculum be improved to help graduate engineers in addressing sustainability challenges? Was it in your curriculum, sustainability?
No.
No?
Short answer, no. So with the sustainability, I actually got my internship with the Geelong Council and started getting exposed to that. And then it was one of my electives, which I later took on because I was working. So
there's some room for improvement there.
There is definitely.
Simone or Eve, was it in your curriculum?
Not really. Like there might have been a few small parts of different projects where you consider the sustainability of your proposed solution. But I think it was missing that big sort of purpose. Like we can do something with this engineering that makes a positive impact. And I think that was lacking a bit in my curriculum.
It was definitely a missing from the curriculum, similar for civil engineering at RMIT. However, there was one elective, and I'm actually proud to say that it was an elective for an overseas travel that included a sustainability travel tour to Bordeaux in France.
Bonus. Geez, that's hard to take.
Yeah. So at least it motivated all of us to actually participate and be a bit more engaged.
I got to go to Patchy Wallach for my study tour, which for those of you who aren't from Victoria is out near the big desert. That was hugely exciting. So I would have loved to have gone to Bordeaux, really, Eve. That sounds wonderful. Ishraf?
Yeah, the sustainability concept is basically experience while I was doing my internship in Germany, I did an overseas internship, so they're mainly really concerned about sustainability while they're doing their projects. So the place I worked is they have the concept of net zero energy, trying to make environment friendly ones, the manufacturing of the airplanes, what they've done there, is a really big concern.
Bit of experience, your sort of early career or just heading into your career pathway. What's your sort of experience with more senior members that you're interacting with? Do they get it? Do you sort of having to be a bit of a change agent when you're going into your workplaces or your chosen career pathways, Ishraf, as you're just starting?
Yeah, I always wanted to be to work with a senior member. It's the main reason is to get some experience and some guidance, because I always had not the fear but the concern that if once I finished all the academic stuff, so when I was just stepping up for my industry, how it's going to really affect to me. So the barrier between the university studies and going as a new beginner to the industry, that's a really big concern for me all the time. So I really hope those days if I have a mentor to be work with or maybe a supervisor will be great for me, and it's really worked. So
So you've got a mentor now?
Currently, yes.
Excellent.
Also, yeah.
Any of our panel looking for a mentor?
I would love one.
There you go. This is a mentoring speed dating site. So Sunny's looking for a mentor. So anyone in the room, catch up with Sunny in the break and offer to mentor him. I ran a program called Kids Teaching Kids for 21 years. Primary and secondary school students. One of the biggest successes of that program was the mentoring that went on. So what sort of difference does it make to you, Ishraf, to have that mentor?
I mean, if I start doing it by myself, so I always have the concern, if I consider a project, right? So I mean, I always have the concern: did I do it right? Is that the expectation what they're expecting? So, but if I have a mentor next to me, he always guided me. Oh, this can be done better than this, or maybe this is the best way to do something like that. So it's kind of a guidance. So it's really helped me throughout my journey as an engineer. Yeah.
Great. Simone, I might come to you on this one. Anne's asked, what did your peers at school think of you deciding to study engineering?
Okay. Well, I guess I haven't asked them that directly. But I will say, I went to all-girls school, and of my grade, I'm the only one that studied engineering.
And how big's the school?
Our grade had 100 people.
Yeah, right, yeah.
And I think that's quite shocking.
Absolutely.
So I think, we need to improve in that area. We need to encourage more girls, particularly younger people, to pursue STEM. I think it just wasn't really encouraged. It wasn't put forward as an option. And when we were doing, science back in school, it really didn't focus on the engineering part, how you can be you can solve problems, you can bring the people element into that, rather than just looking at graphs of motion and velocity and chemical equations. So I think we can make it more exciting, and that will really help bring in more young engineers.
Excellent. Love the solutions there, son. What did they think? What did your friends think when you said to your...
They were definitely really happy for me because being an international student, I got into an Australian university, which was a big achievement for myself. And India being a country where I'm from, so it's engineering, everyone wants to do it, but it's hard to get into. So definitely my family, friends, like they were all very happy and confident. And I still remember my dad said to me when I was about to board my flight, he said, "Sonny, you're gonna be the change maker." And I still remember that. So yes, that was their reaction.
Oh, anything where you talk about family gets me in the heart, Sonny, so I'll just gather myself a little bit. That's beautiful, so having your father say you're a change maker. I think that's you can't get better than that, can you really? Eve, what about you? What did your friends say?
Well, I actually finished high school in Poland. So in Poland, it's sort of normal for women to go into STEM courses. It's actually, the split is roughly 50-50 of the statistics.
Why is that? Like this is, I mean, it's been a big conversation of yesterday in terms of, the shortage in the profession. How do we make workplaces more welcoming? What do we do to get? Why is it so successful there?
I think just Poland, at least particularly, is that people want their own independence. They sort of want to move away from family, want to make their own money. And in Poland, it might be a little bit more difficult, with other jobs. Engineering or STEM type of subject actually seem to be providing very well pay compared to other industries. So people maybe feel a little bit more empowered to some extent in taking, grasping that opportunity and doing it for themselves. And it doesn't have as much stigma because naturally they had years of generations of doing that already. So you don't have to convince people that it's the industry. You don't have to convince people that there's also mentors available. That is, you can see the people you want to be, particularly with female sort of mentors and someone to look up to.
Excellent. There's a question here, I think it's from Christina. Do you think the engineer of the future will utilise more technical skills or more human skills? Anyone want to take that one? More technical or more human skills? Ishraf, you want to have a crack at that?
Yeah, sure. I mean, most of the people's understanding is like just having like the theoretical understanding at the uni is just far enough. Like as I mentioned, like to having that barrier between like academic studies and the working at like the workplace. So having technical skills are really important. For example, like just a funny story. So like most of the people, they like even in the uni, like they don't want to go to the labs and they don't want to do the practicals. They don't want to have any sort of like any skills to improve their skills, so they just stick with their academic studies, just working the lecture notes and just doing the exams, and that's all. But having technical skills is really important. If you are just moving from the academics to the workplace, it's really important. Otherwise, it's going to be struggle and might take some long time, or maybe as I said, maybe 2060, we still will be not in a good position for sure. Without.
Ishraf, we'll stick with you because there's a question here from Anamutra, and that question has just jumped and is jumping again. There we go. So hopefully a relatively quick one, because you should, as an EV enthusiast, you should know these stats. I'm putting you on the spot here a little bit. What's the true cost of an EV when you talk about emissions associated with the lithium and the material used? So I guess the embodied energy in an EV versus what it means in terms of emission reduction. To have those stats at your fingertips?
Yeah, I mean, honestly, EVs are expensive at this stage because the main reason, like the manufacturing process, they're talking about the rechargeable lithium batteries, like finding resources of lithium, cobalt, like those kind of like elements is limited. And also when the production of the early production, for example, taking the raw materials related stuff, it affects the climate very much. So that's like kind of a challenge we are facing. And also, the initial cost like of the EV is like, of course, it's expensive. So that's a concern. In Australia, as I mentioned, it's just like 8.4, but like some countries we need to consider, like especially Europe and the US and of course China, they increased like even the public transport. There's like 40% of like the million of like public transport is like using electric public transport EVs. So in Australia it's limited. I agreed with that, but like because it's like they got like financial barriers as well. But
what about that comparison between emissions saved from an EV versus the embodied energy that's in the production of an EV? I think is the question. And I think, look, it probably touches a little bit too on our circular economy panel yesterday. where, you know, for EVs to be truly sustainable, things like the recycling of batteries and all those sorts of things have got to really reach scale as well. So any sort of figures you can throw at us, or maybe you want to come back to us in the break?
No, I mean, like, if talking about the rechargeable, like, lithium batteries, I mean, like, they're using, like, kind of a system called, like, ultrasonic technology, which if you consider the climate change, it will recycle in a better way. But as I mentioned, in EV still we got some challenges. So as I mentioned, like, choosing raw materials is a really big concern. Only Argentina got like most around like 24 of the whole like the materials we are using for the manufacturing of the batteries, but it's really still affect the climate. So
big opportunity for engineering solutions, I'm hearing,
yes,
Ishraf, isn't there? Look, we're coming quickly to the end of our time. We could sit here and kind of converse all day. There's lots of questions that are flowing in. What I'd say is, for anyone in the audience who's asked a question that we haven't been able to put to the panel, our panellists are going to be here at the break. Come up and have a conversation with them. You know, if you've got the opportunity to be a mentor, that can be quite informal as well. It doesn't need to be, you know, one call every month or anything like that. It can be, hey, check in, you know, shoot me a few questions on email or anything like that. But I want to close, which is a bit of it's in line with the question from Helen Fairweather about what the greatest opportunity you see for the world to pivot from the trajectory we're on. But I want to slightly reframe that. We're on the eve of COP28. What message do you want to give? We've got a whole room full of engineering leaders in the room. What room do you want to give the leaders today here with regards to climate action? So this is your chance, your one big chance, the big message that you want to leave them with. Simone, can we start with you?
Yeah, for sure. So I think we need to challenge the status quo. We need to come in and make change and be a bit innovative with it. And we can't just keep doing things the way that they've been done for the past 3 generations. We need to change things. And I think it's a good opportunity for us as Gen Zers and younger engineers coming in. You know, we ask questions, we challenge things, we say, why do we do it like that? So I think sort of, yeah, be open to changing the way we do things and being innovative and challenging the status quo.
Great. Sunny?
So yeah, I would say a similar thing. So start collaborating with each other, as I said earlier, and start innovating so that we have something that we can follow as an example and then we can work on in future. So conferences like this is a great space for you all to talk together and, you know, work together, and like, again, collaborating with universities and partnering with them is also a great thing that I would highly encourage as well.
Yep, great. Eve?
So yeah, to build upon Sunny's collaboration, it's worth highlighting that it's all of our responsibility. So whether you work on standards, your client side, design, construction, manufacturing, we need to collaborate together to make sure that even products such as, for example, the recycled waste, that becomes the norm, and that becomes, the status quo.
So we've got a good theme going here. We need to do things differently. We need to collaborate in doing that. And I guess challenge the status quo is probably a thread here. Ishraf?
Yeah, I think as engineers, to find solution, we always need to be initiative, because we can't change a community, you know, like even if you consider like a country like Australia, but still we can't change the whole community. But as engineers, we always need to be prioritized and then like need to find the better sustainable solutions for these matters, and that will be great. It might take some time, but it'll be great.
Excellent. Please thank our panel, our Gen Z panel.
The world is changing, and we have the power to help. As a global community, our collective creativity will shape solutions to ensure it changes for the better.
We are the UNSW Faculty of Engineering, where world-changing action starts with fearless thinking. The university is really a powerhouse of innovation in a number of different respects.
The way we teach, we have a huge array of industry projects. We have many spin-out companies from both staff and students, and a huge array of cutting-edge research.
Engineering is one of the disciplines that can change the world. Engineers make things that have tangible impact to the environment and to the society.
We sometimes think in different ways to other people. And it's that constant change mindset that we have as engineers. It is constantly looking at something over there and saying, God, but what if we did this?
As engineers, we have very complex challenges to solve for society, and the only way we can come up with appropriate solutions is if we really do consider all people within our society.
Diverse minds, diverse groups, diverse people are what gives us different approaches to problem solving. And I think some of the best solutions that we get come from different perspectives on the problem.
Creativity and imagination, I think, is at the heart of the research that we do. What we can expect in 100 years is new areas of investigation and new areas of technology that just don't exist yet. One of the most exciting things is that in a matter of just a few years, we could be working on things that we don't even know anything about right now.
To our students, when we teach, we actually get them thinking about sustainability throughout all of their courses, so that from the get-go, they're actually considering, how do we do this more sustainably?
Finding new renewable sources of energy, renewable sources of material, making use of waste material, and also looking at the impact on the environment of a lot of the processes that we have.
So our engineers take the theory and put them into practice. We're able to develop the solutions that we need in order to have a sustainable future.
At UNSW Engineering, we don't just talk about it. We actually get students hands-on and doing it.
I wake up every morning just proud to see the development of these students, seeing them standing proud, talking about what they're doing with such confidence is just incredible.
Innovation is really our lifeblood. We're almost not doing engineering unless we're innovating.
Our work touches lives, communities, and the planet. It's a huge responsibility, but also a huge opportunity. We get to think big, aim high, and create a better, smarter world. That's the power of engineering. It's not just a job, it's a mission to drive us all forward.
FSA fire code is a paint. We call it more technically as an intermittent paint for exterior and interior applications. What intermittent means is that the layer grows in time as it's subjected to high heat, and that layer acts as a barrier to the fire or the oncoming heat to the walls of the houses, for example. And because of that so-called intermittent or char layer, it holds itself even though it is on a vertical orientation. Basically, if you have an additional layer protecting the house, it just deflects the heat, disperses the heat so that the fire will not actually penetrate into the walls of the building themselves, and that's how they protect them. FSA fire code supersedes actually a lot of these paints. They're in the market because we have even tested all these commercial paints as well, and I don't think that they can reach the BAL40 as what FSA fire code has managed to do so. So BAL40 means that you have a rolling fire going around your house, and we have tested that the paint could withstand this high intensity heat or radiation for at least half an hour or more. BAL50 is meaning that you have a direct flame impinging on the house itself. So we are confident that even with a direct flame being attacking the house in a bushfire-prone area, we believe that the house will still survive. We then need to look at how we can substitute or basically replace some of them with more commercial grade ingredients. And what we have ensured throughout this process is that even though there is a one-to-one direct substitution or similar substitution, we're still maintaining the performance of the paint itself. I think that this bushfire season could be quite as bad as a couple of years ago. So I think that this paint maybe serves as a reminder to people that you need to look after your prized possession, and I think this paint would actually help to protect the house if there is an event of a direct bushfire attack.
It's a crazy idea for undergraduate uni students to build a race car from scratch. But we wanted to do more than that. We wanted to build the world's fastest electric race car. And it's been a long 3 years to get here. We've engineered everything for this car from the ground up, from the aerodynamic design to the manufacture of bespoke parts, everything from the drivetrain to the control systems and even the software used to run the car. And we did all of this during the pandemic. But building the car is only half the job. As engineers, we knew we had to test it, break it, fix it, and then test it again. The team have put everything they have into this project. Today, we find out if we've got what it takes to get the Guinness World Record. The fastest electric vehicle over 1,000 kilometres on a single charge. We unfortunately don't get the Guinness World Record if it goes over 12 hours. We'll have a GoPro in the car, a GoPro on the side of the road, and they will film for all 12 hours. We've got 3 different timekeepers, and we have to completely seal our battery so that it cannot be charged, so that Guinness can verify that we didn't use any electricity from the grid to complete the record. On go.
3, 2, 1, go.
One of the things that we are specifically watching is the battery voltage. That's a pretty important metric as it's not a linear decline. There's actually a battery state of charge curve which has an exponential drop-off towards the end of the battery life.
Throughout the day we'll be looking at the power used and the energy used over time, from motor temperatures to state of the battery. And then my job is to get all that data up into the cloud and then in a way for the team as a whole to visualise it and to make decisions based on what the car is doing.
I'm assuming because you haven't said anything that it's fine going a bit faster than 90.
Yes, you're limited to 93 as well.
It sounds simple enough. 240 laps, non-stop. But there's still a lot that can go wrong. On a single charge, battery management is our main concern.
I'm Paolo, but I'm on a hill.
Copy that, we're right behind you.
If any problems come up, we only have 15 minutes to solve it, or we're disqualified.
What's going on, but it's super laggy right now.
We have 8 minutes remaining. Any updates?
No, not yet. Our issue was a false positive error that came up within the battery management system. The bigger cause of problems was the downstream effects that caused. Problems with the powertrain and control systems that had gone into a fault state that we hadn't seen before. We traced the logic flow and where that critical error was that we could also reset.
3 minutes remaining. Is the car moving?
Negative. We used pretty much all of our 15 minutes to get us back on the road.
Try now. Yep, let's go. Yep, we're running.
We decided that we'd actually put a passenger in the car so that if that fault came up again, they'd have a laptop and they could clear that error. We lost a lot of time. The issue became how fast can we go and can we actually maintain this pace with how much battery we have left.
We just need to trust the numbers. Yeah. The numbers are in our favour. Crossing the line, that feeling, is something I will always have with me forever. It was a pretty special moment to be there with the whole team after those 11 hours and 53 minutes.
Did we do it? I think we did it. Yeah.
see it cross the finish line, it was very surreal. It's the best experience. I think anyone in Sunswift would tell you how incredible this opportunity is. And if you grab it and run with it and don't let it go, it will serve you so well, not only for university, but for the rest of your life.
Hi, I'm Serena.
Hi, I'm Sadia.
And we're part of the Drought Resistance Uganda team at UNSW Engineering.
Our team has just gotten back from our latest trip to Uganda, working directly with the Love Mercy Foundation, or LMF for short, and the African STEM Education Initiative, or ASEI, on a number of projects involving water filtration and agricultural drought resistance. With water scarcity issues on the rise, the focus for the trip was to conduct relevant field research, as well as engage with as many different stakeholders as possible to deepen our understanding of the context of our project. The aim is to use this research to inform the development of appropriate and sustainable solutions to improve agricultural practices and water access for the community. The months leading up to the trip were spent researching various agricultural practices, prototyping our UVC water filtration device, preparing for troubleshooting weather stations in country, organising taking equipment over, and of course, planning our trip activities. And before we knew it, we were packing our bags and getting ready for the airport. After a long journey, the Drew team finally made it to Kampala, and we got straight to work.
We started our trip in Fort Portal, where we finally got to meet the ASEI team and piece together the microfactory system with our UVC prototype. The system is designed to use UVC light and a charcoal and cotton filter to treat water with E. coli and theoretically produce clean water. Our next goal was to put it to the test. We tested samples from 3 different water sources for turbidity and E. coli, and the results were very promising. We also set up 3D printers to increase the ASEI team's accessibility to piping components that aren't readily available in country by allowing them to print out the components themselves. Our days with ASEI also consisted of visiting Kiabambe Girls Secondary School, talking to the girls about a future in STEM, as well as learning about their water storage and treatment systems. On another day, we visited the Jaka refugee settlement, where the Oxfam staff walked us through their water treatment process and facilities. We also visited Gulu University and connected with academics and students from the Faculty of Agriculture and Environment. After each day's work, the afternoons were spent together with the ASEI team, doing local sightseeing, beautiful hikes, and even a safari. After saying our goodbyes to the ASEI team, we headed to Lira and were warmly welcomed by the LMF team. Together with the LMF team, we met with local farmers and community members and were introduced to some of the core challenges they face. We began our work with LMF, including troubleshooting the weather stations, visiting community plots, conducting fieldwork, and having lots of insightful discussions. We also got to witness firsthand LMF's Sense for Seeds program take place and had the opportunity to talk to some of the women involved in this fantastic initiative.
Being involved with Drew has shown me the impact engineers can have on society, and that what we learn in the classroom can help solve real-world problems. It teaches you to be agile, the value of interacting with people with different perspectives, the importance of working in a team, and that you never know when the fluid mechanics will come in handy. These 2 weeks were full of invaluable experiences, and so on behalf of Drew, we thank everyone that made this unforgettable trip happen. And until our next trip, bye!
Welcome back to the 24-hour Global Stream Studio. I am Tanil, and I'm going to take you through some really cool social media that's currently happening out in the world. You'll see behind me, we have some really cool social boards happening in the studio here. Please use hashtag World Engineering Day, or we can't see how you're celebrating. It's really important that you do that. I've got some super cool things that I've been seeing online over the last couple of hours, and I'm going to take you through them right now. So let's have a look at what's going on in social media land.
This amazing post popped up a little earlier today. We absolutely love it. It's from Open Bright. It says, "Today, we recognise the pivotal role engineers play in shaping our world." We absolutely love the photograph that they've used, and it's hashtag World Engineering Day, hashtag Women in Tech. Good job, Open Bright. The next one I'm going to show you is hilarious. We absolutely love this video that's been custom made by Tech. Its description says, "Celebrate and eat cake for UNESCO themed World Engineering Day." Let's watch their awesome video.
Hey, Kakwa!
How great is that? We absolutely love it. It's so great. Good job there, Tech. Next up, this is a really cool video that I've just seen a couple of days ago. It is from Frost Science, and it is to promote the upcoming World Engineering Day week that they are having within their facility. But you can see from this video, it's filmed from their World Engineering Day celebrations last year. Obviously, it's hard to get this type of content in the heat of the moment because it is obviously happening at the same time, but I think it's a really great thing for us to watch.
Welcome to Frost Science, where we're celebrating World Engineering Day. And this is our Tech and Engineering Day event. I'm Dr. Cassie Freund, and today we have numerous local partners and local scientists here teaching our guests about the technology around them and the engineers who created it. Today we have lots of great activities like robotics, 3D printing, and guests can even try their hands at computer coding.
That is so cool. Well done, Frost Science. I can't wait to see the footage from this year's celebration in your ad next year. This is an amazing video that I noticed earlier today, actually. This is from Wago, India. Engineering shapes our world. I love this video. Let's go and watch. Good job, Wago. I love that. I love this caption. Engineering shapes our world, propelling us forward with innovative technology. On World Engineering Day, Wago salutes the brilliance and perseverance of engineers worldwide. I love it. Love, love, love it. Congratulations and great job. Just a little bit of a event profile here from CJK Fire and Safety. This is happening today. So just a little bit of an event plug for them. I love this one. This is a chairperson of the Engineers Registration Board, the ERB, who's giving an announcement speech this morning. Hopefully we might see some video footage of that over the day. I always love to have an internal social piece available. This is the UNESCO official post that went out 18 hours ago. Always so lovely to see females profiled in the engineering community, and this is obviously doing just that for us as well.
That was so cool. I can't believe how things are progressing online, and I'm so excited to bring you another social media update in the next few hours. Again, please, hashtag World Engineering Day, otherwise we won't see it. I really hope you're having a wonderful World Engineering Day 2024, and I'll see you here in a few more hours to check on the social media then. Thanks, everyone.
In my nails, I have a computer chip, which allows me to pay for things. I can use it as my Oyster card. I can use it to pay for drinks. The most rewarding thing about being a robotics engineer is the fact that it lets my creativity shine. No 2 days are the same for me. Sometimes I'm working on a humanoid robot. And other days, I'm having meetings for my workshops. Making something from scratch is so fulfilling. The thing I love the most about robotics is machine vision. I just think it's amazing that you can give eyes to a robot, like a robot can have eyes. How is that possible? How can it see and perceive the world as humans do? When I speak to people and they ask me, how did I get into robotics? How did I get into engineering? I always say, just having that passion and that curiosity is the first step. From a young age, I was always very tenacious. I was always trying to pull things apart, put it back together again. At the time, I didn't know that I was basically engineering. I'm going to do all I can to help people from underrepresented backgrounds, people who always wanted to get into STEM, but never thought that it was for them, whether that's because they were female, or maybe they're from a disadvantaged background, or there's financial limitations. I wanted to show that you can literally be an engineer anywhere. You can't be what you can't see. And for me, representation is everything. One of the most beautiful things about tech is that it allows you to dream, it allows you to imagine.
We are working with professional engineering bodies, working with higher education, working with government, even the public, to create fit-for-purpose engineers.
The Royal Academy of Engineering, through the African Catalyst Project, funded the Federation of African Engineering Organizations in building our capacity of the Secretariat and the capacity of other engineering institutions across Africa.
Engineering is what will develop Africa. And we are looking at engineering education and harmonizing engineering education. That is very important. We are looking at professional engineering qualifications and trying to harmonize that across Africa.
One of the eventual outputs of the kind of catalyzing that we're doing will be potentially that we have agreements with regard to standards, professional engineering standards that are transferable and compatible across countries.
The Institution of Engineers Mauritius, the main role of this institution is to help build the network of engineers locally, and it helps the local engineers network with regional and international engineers on some important topics.
The funding enabled us to build capacity and understanding around the requirements of the Washington Accord.
Washington Accord is a multilateral agreement between the signatory countries, and this is very important because this will help increase mobility of our graduate and recognition of the engineering degree.
There are many women now that are actually in leadership positions in these professional engineering bodies in Africa, acting as role models for younger girls to take up STEM subjects and eventually influence policy.
She Engineered 30% Club is an initiative to get engineering businesses and organizations to build 30% female in their workforce by year 2030.
So that inclusion, that equality, diversity is also very much embedded in what the Africa Catalyst program does.
Before the opportunity for funding that we received through the Royal Academy of Engineering, we had been having a number of discussions around the role of engineering in supporting our country achieve the Sustainable Development Goals. It was important that we had a diverse range of stakeholders, because if we're going to build sustainable and resilient infrastructure, we need various stakeholders to come on board, from national to regional to community.
So we have actually reached more than 6,000 students and professionals in sub-Saharan Africa, working with professional engineering bodies whose role is to share knowledge, regulate the profession, and also influence policy. But much more importantly, that the kind of investment, the kind of spending that the Academy is putting towards this, and the return that we are actually getting on that, is something I haven't seen before. The Africa Catalyst program is doing exactly the right thing in developing both the talent pool and the talent pipeline in a sustainable way through its work with professional engineering bodies.
The Africa Prize for Engineering Innovation is Africa's biggest prize dedicated to supporting and upscaling engineering innovation. It stimulates, celebrates, and rewards innovation and entrepreneurship across Africa.
Since 2014, the program has supported more than 130 entrepreneurs working in more than 40 countries across the world. The prize provides business training, accelerates the innovation of engineering products and services that deliver positive impact. Entrepreneurs are also connected to a global network of alumni. This provides a supportive community that fosters the development of partnerships and collaboration.
Over 10 years, the prize has supported innovators from a wide range of engineering disciplines to raise over $39 million. The innovators have created over 28,000 jobs across the continent, with their product and services supporting over 10 million people. The Africa Prize for Engineering Innovation elevates innovators who shape African society, protects its environment, and energize the economy. We are always on the lookout for innovative engineers to take part in the Africa Prize and support us to make this happen. Visit our website to find out more.
In the heart of every city, the heartbeat of progress is driven by innovation, change, and the relentless pursuit of a better future.
This is where you meet the engineers of today, the stewards of tomorrow, the catalysts of change.
We are living in a world at a crossroads. Climate change, a crisis that knows no borders, threatens the very fabric of our existence. But there's hope on the horizon.
We, the young engineers, are instrumental in tackling this global challenge head-on. We have the technical know-how, the ambition, and the vision to make a difference where it matters the most. We must leave no one behind.
The message is clear. Our planet's future relies on our industry changing. We are critical in driving sustainable development. Don't just take our word for it. Let's hear from climate change makers.
My message to young engineers is to be bold.
I think you should not underestimate that influence you can have and really help us for a better future.
If you want to save the world, it's the engineers who are going to be the front line.
You can have a voice and get the confidence to be part of the solution. Make a difference, and it starts now.
First, I salute you for choosing to become engineers. We will need you big time in the years to come to do the things we know work, to innovate and come up with new solutions where we can produce energy, electricity, without destroying the atmosphere and the climate.
Your fresh perspectives are the seeds of innovation. You have the power to reshape the world.
The EngineeringChange campaign will empower a coalition of young engineers to steward sustainable development through capacity building and collaborative initiatives.
Will you join us to engineer change?
Good day, everyone. It is my honor and pleasure to come before you today, the World Engineering Day that we are celebrating on this day today. I am Professor Saifur Rahman from Virginia Tech. I am also the 2023 IEEE President. I am very happy to have this opportunity to come before you today and talk about what we as engineers can do to address the climate sustainability challenges the world is facing today. Let me go ahead and start my slide presentation where I'll show you what are the challenges and how we can deal with that. Thank you. Let's move on. Hello, this is Professor Saifur Rahman from Virginia Tech and the 2023 IEEE President. I wanted to draw your attention to a couple of things on my short talk this morning: clean tech solutions and climate sustainability. As I go through this next 15 minutes or so, I will highlight what I mean by this. So this is a talk being given on the World Engineering Day, and I have posted the slides for this talk onto my website, www.srahman.org. You can find it there. Okay, let's move on. So we talked about climate sustainability. So why is that an issue? What is causing the challenges in climate sustainability? Carbonization. As we burn fuel for transportation, power generation in buildings, factories produce CO2. That CO2 is a primary cause for climate change. So this is the issue that we are facing. Carbonization is challenging climate sustainability. Before I go further, you'll ask this question, what do you mean by carbonization? Well, carbonization is this. As we go back 800,000 years ago to look at the atmospheric concentration of carbon dioxide, this data comes from the North Pole. North Pole has, to speak of, no human habitation, not too many animals, no factories, no nothing, but air is pretty pure in terms of containing other gases that are seen on the ground and other poisonous gases as well. So scientists have gone back that far back using some ice core samples to see 800,000 years ago, every 10, 15, 20 years, what has been the change of CO2 concentration in the atmosphere on the North Pole. Okay, you see the numbers from 800,000 years ago till now, 1900s or so, has been at or below 280 parts per million. Some spikes once in a while, but never exceeding that number. Beginning 1950 or so, it has been going up almost vertically. Currently, that number is close to 420 plus parts per million. What happened in the 50s? That's when the world started to burn a lot of coal for coal-fired power stations primarily. And coal was used for ships and other forms of transportation. That's why it went up so fast. So we'll look at that for a shorter time frame in this slide here. Now I don't go back 800,000 years back. I go back to 1750. Why 1750? I'm coming to that. You see the numbers 1750, 1780, 1810, 1840, 1850 or so. On the right-hand side scale is CO2 emissions in billions of tons. The blue line. CO2 emissions in billions of tons. And the pink or red line on the left is atmospheric CO2 concentration, parts per million. That number stayed below 280 for a long time. Beginning late 1800s, it began to speed up. What happened at that time frame? Mr. James Watt from Scotland, born in 1736, died in 1819. In late 1700s, he invented the steam engine, the James Watt steam engine. So to make steam, he burned coal. Steam has many applications, including power stations, steam turbines, and many things, even for cleaning purposes. So that's where the world learned to burn more and more coal to make steam and do their job. And that's why the concentration of CO2 in the atmosphere began to rise very fast. And in 1950s to 1990 went up, and they're still going up pretty fast. So today, 2024 timeframe, the CO2 emissions per year is close to 40 billion tons per year globally, 40 billion tons CO2. And the CO2 concentration in the atmosphere has gone up to 440 or so parts per million. That's the carbonization situation. So that is the carbonization. Now I look at what are the impacts of carbonization. Well, here you go. Carbonization means the atmospheric CO2 is holding back the release of heat from the Earth. Again, the same numbers we have looked at so far. Between 1850 and 1900 or so, the numbers were 1925, plus minus 0.2. After 1950, no minus anymore. This is the global temperature change from pre-industrial levels in degrees centigrade. The global temperature change in pre-industrial levels. So today, 2024, it's about 1.2 degrees more than what was the number in pre-industrial level. What is pre-industrial? Before 1860s or so. Now, this is 1.2 degrees. If you go back to UN conferences, the climate change conference in Paris in 2015 said the world should limit the growth of CO2 caused temperature change to 1.5 degrees centigrade. It's spelling DEC, not DG, not DEC. So we are almost there. Temperature rise 2 degrees centigrade is acceptable in many quarters. But if you go beyond 2 degrees centigrade, it's point of no return, meaning you will have a feedback loop so that things cannot go back to normal anymore. That's the impact of carbonization showing through the higher atmospheric temperature in the ground. That's the temperature issue. What are the other things happening? It's not only global warming. You get more fires, more on the upper right, flooding and drought. Flooding and drought are two opposite things. So you can imagine, because of the atmospheric changes of CO2 concentration, we have many things: flooding, drought, forest fire, and the like. So then the question is, obviously, as engineers, we ask the question, there's a problem, how can we solve it? So how do we decarbonize? The two groups, two parts of the world. One is industrializing countries who are developing world. They need sustainable, affordable, and accessible energy sources. So sustainable means it cannot harm the atmosphere, it has to be affordable by them, and it has to be accessible in all parts of their countries. So this is the challenge, affordable and accessible. Well, let's look at this. So this is the tension. Industrialized countries need to use low-cost energy as much as possible, which is of course understandable. But the developed world is slowing down the use of carbon-related fuel, except transportation. And they're saying if the industrialized world only reduces carbon emissions, an industrializing world keeps on growing the carbon footprint, then the whole world suffers. The question is, who does what and what is acceptable? So we have proposed a 6-point solution which can be practiced, if not all 6, by most countries developing and developed. And I'm going to present that to you now to see where it's coming from. This is a product plan that I put together to reduce carbon emissions. It is done in many countries, and not all of them, most of them, but this is possible for everybody. First of all, use less energy, make your systems, heating, cooling, air conditioning, whatever, water heating, more energy efficient. If you use less energy for the same output of your convenience, heat, cool, and so on, then you burn less fuel. Very simple. So high efficiency means burning less fuel to get the same end product. Second is, no matter how much we shout and cry about shut down coal plants and oil plants, it is not going to happen for next 25 years. That's not possible. Why? Because globally, there are more than 1,000 coal-fired power plants running, more than 1,000 coal plants running. So it is not going to go away right away. And many more coal-fired power stations are being built as we speak. So my point is, yes, if you have to burn carbon-based fuels, use more efficient power plants so that per unit output, you use less coal or less oil. That's possible. Technology exists. Number 3, yes, we can talk about renewables, but unless you have some kind of large-scale storage opportunities, renewables are not very practical in many cases. Then I said promote more renewables. Of course, renewables means low or no carbon fuels. Promote them. At the same time, I said accept some nuclear. Nuclear fuel is carbon-free by design, but there are concerns about nuclear power because of history, like Chernobyl in Ukraine many years ago. Recently, 2011, the Fukushima disaster in Japan has caused a lot of public opposition to nuclear. But there are new technologies which will be safer. Finally, promote cross-border power transfer. No country in the world is 100% sufficient in electricity production within their borders. It's very few, I shouldn't say no, very few countries. The US buys a lot from Canada, France sells to many countries in Europe, China sells to Vietnam and neighboring countries. India buys from Nepal. So this is an opportunity. If we can do more of that, we'll be using less coal fuel in our own countries and produce power from, use power from other countries for the country's use. So first of all, energy efficiency. We have done studies which showing if you control the temperature for air conditioners, meaning raise it by 2 degrees or so, when you are in the building, you can save 10 to 15% electricity just by using higher temperature air in the building than you are used to in most cases. That's one. Lighting is even more impactful by dimming lights, by scheduling when lights should come on when nobody's in the building, like not nobody, very few in the building. At lunchtime, why keep the lights on full capacity? So these are options we can pursue. Second is replacement. If you replace an incandescent light bulb, like you see on the lower left, with LED light bulbs on the upper left, you save 85% of electricity, 85%. That means 100 watts of light, worth of light from incandescent is 100 watts. If you use the same lumen from a LED lamp, it's only 15 watts. A big difference. Okay, moving on down. As I said before, if you have to use fossil plants, use highly efficient fossil plants. And there are examples in many parts of Europe and other countries where combined cycle gas and steam plants are using ultra supercritical steam to reduce fuel consumption in power stations. Next is carbon capture storage. As I said, we will be burning coal and oil for many years to come, producing CO2 if there are strong efforts to capture that carbon and store it somewhere. It doesn't come out underground or under the ocean, then you are able to extract CO2 being emitted from power stations and not adding to the CO2 load going forward. So other storage solutions besides batteries are hydrogen storage, which is a promising technology, but it needs a lot of investment today. Next is renewables. We know wind is a good one globally. This is the data for last, 20 years or so. The wind output generation has grown 10 to 26% year on year, so that we can see where wind is today. Number is 21 data, 837 gigawatts. By the end of 24, it's more like close to 1,000 gigawatts. That's wind. If I look at next one, solar. Solar has multiple applications. On the left is the ground-based large-scale solar in megawatt scale. On the right is rooftop solar, 10, 15, 20 kilowatts. Even though that rooftop solar cannot serve the full needs of this building, but it can serve the common lighting, security, and things of that type. Anything you can save from using oil-based is useful. So this is a summary. At the end of 2021, globally, we had 942 gigawatt or 942,000 megawatts. China had a third of it, almost 32%. US next 13%, Japan 8%, India 6%, Germany 6%, and so on. So this is happening, but it needs to happen more. So then the question is, how about hydro? Hydro is a renewable fuel, of course, but you cannot have hydro anywhere. You can put solar everywhere, but hydro is very site-specific. And in the developed world, hydro has been almost fully developed. No other rivers left to dam. So this is a limited scope going forward. Finally, number 5, advanced nuclear technologies are very promising because they're safer and they are smaller in size, so risk is much less. This is an example. This is a 60 megawatt small modular reactor, small 20 meters tall, 2.7 meter diameter, and weighs only 590 tons. And that's an example we'll see more and more. Finally, cross-border power transfer. This is an approach that being talked about internationally. International Energy Agency, IEEE, has identified 3 ways to do cross-border power transfer. One is bilateral, meaning one country buys and sells from the other country. Multilateral, that is one country buys from more than one or sells to more than one. And unified means a network of countries like in Europe, which buy and sell from each other as needed. So those are the examples. So this is it. Thank you very much. I gave you the website again, srahman.org, which has the slide deck if you want to know more. Thank you very much. Bye-bye.